This image was created on a local AI chip, but hidden inside its pixels may be an identifier issued by a remote server. That is the surprising finding from reverse engineer Xusheng Li, after examining the AI features inside Microsoft Paint and Photos. The headline sounds simple: local image generation, invisible watermark. The actual system is more interesting and more complicated. First, an important limit. This is not about every picture opened or drawn in Paint. It concerns images produced by its AI generation features. On supported Copilot Plus computers, those features can run a stable diffusion model on the machine's neural processing unit. So the expensive image synthesis can happen locally. Your computer performs the inference instead of uploading every pixel to a cloud generator. But local inference is only one part of the pipeline. Before generation, the text prompt still travels to a Microsoft service for moderation. According to the reverse engineering, that service sends back a revised prompt and a server-issued generation identifier, formatted as a GUID. A GUID is a 128-bit identifier. It can distinguish one generated item or event from another without describing its contents. Paint then combines the revised prompt with your sketch, runs the image model locally, and produces a new bitmap on the NPU. At this point, a component called Watermarker.dll modifies the locally generated pixels and embeds the server-issued identifier invisibly. This is not ordinary metadata sitting beside the image. The payload is written into the pixel data by a function named writeWatermark. The researcher traced that function through Paint's generation path. If watermarking fails, Paint appears to fail the entire generation instead of returning an unmarked result. That behavior suggests the hidden mark is not an optional decoration. In Paint's local AI workflow, it is treated as part of a successful output. Now notice the second watermark. Paint also offers a visible Copilot logo that can be placed in the corner of generated images. Users can control that visible logo with a setting, but the visible setting and the invisible pixel watermark are separate systems. Turning the logo off, therefore, does not necessarily produce an image without the hidden payload. It only removes the mark you can see. Microsoft Photos reportedly contains a matching watermarker library and similar local stable diffusion paths for image creator and restyle image. Photos appears to embed the same kind of generation GUID, although its error handling differs when watermarking cannot be completed. There's also a third layer, C2PA, an industry standard for recording content provenance in supported image files. C2P, a manifest, can describe how content was created or edited, and can be cryptographically signed so later software can inspect its history. Microsoft publicly says generated images contain a C2P, a manifest. It also explains that online services perform filtering and abuse prevention. The researcher argues that those disclosures do not clearly explain the separate GUID, embedded invisibly into the pixels of locally generated images. The distinction matters. File metadata and pixel-level watermarking can survive, fail, or be removed in different ways as an image is transformed. Paint also limits direct AI image exports to formats such as PNG, JPEG, GIF, and its own Paint format. Those formats can preserve C2P information. Classic bitmap files do not provide the same convenient place for an embedded manifest. Does the hidden GUID identify your Microsoft account? The research demonstrates a generation identifier, not proof that the pixels directly contain an account number. Microsoft may still possess server records connecting prompts, device identifiers, accounts, and generation events, but that linkage is a separate claim requiring separate evidence. There are legitimate reasons to mark AI content: provenance, abuse investigations, disclosure, and distinguishing synthetic media from camera photographs. There are also legitimate transparency questions when local generation depends on remote moderation and silently modifies the resulting pixels. The phrase local AI can therefore be misleading when treated as a complete privacy guarantee. Computation, moderation, logging, signing, and watermarking may happen in different places. The better question is not simply, does the model run locally? Ask what leaves the device, what returns, what is stored, and what is embedded in the output. For sensitive work, inspect product documentation, network activity, export formats, and provenance data instead of relying on a single local label. The core finding is narrow but important. An image can be generated on your hardware while still carrying an identifier supplied by someone else's server. Local compute is real, so is the remote data path. Privacy depends on understanding both.